We can reduce a fraction to its simplest possible form by dividing numerator and denominator by the greatest common factor. However, in practice, for a problem like this, finding that greatest common factor could take more time than actually iteratively reducing the fractions to simplest form. Going through the prime factorization of 216 and then the prime factorization of 243, comparing them and determining the greatest common factors will be a little lengthy process compared to a simpler approach as follows. Each figure shown is divisible by 3, and we can see that from the figures 2 plus 1 plus 6 in 216 equal 9, which is divisible by 3. And the figures in 243 are 2 plus 4 plus 3, which also equals 9, and that is, of course, divisible by 3. In fact, they're both divisible by 9, but it's almost easier to do it step by step. Let's start with 3. 216, 3 times 70 is 210, and that leaves 6 left over. 3 times 2 equals 6, which adds up to our 216. So we have a total of 72 we can reduce the 216 to. Likewise, 3 times 80 equals 240, just shy of 243. And then 3 times 1, adding that, which equals 3, makes the total 240 plus 3, or 243. So we can reduce the denominator dividing by 3 to 81. Now we've reduced the fraction to 72 divided by 81. And 72 is 9 times 8 from our multiplication tables, and 81 is the square of 9, which is 9 times 9. And that means our 9s on numerator and denominator will cancel, leaving only 8 divided by 9. And that is your simplest form of fraction. Solving it this way is easier in most cases than actually finding the greatest common factor, although that is the way in one step to reduce the fractions to their simplest form. And knowing that might be useful at points in the exam.